Okay, good day, viewers. The topic before us is polygons. A polygon is a plane closed shape bounded by three or more straight sides. What we are saying in essence is this: we have something like this nature. This is a polygon. A closed shape bounded by three or more straight sides is a polygon. We have a regular polygon. A regular polygon is a polygon that has equal side and equal angle. For example, equilateral triangle is a regular polygon. It has three equal sides and then equal angles. Then we have four-sided polygon are called quadrilateral. Five-sided polygon we have we call it pentagon, six-sided hexagon, seven-sided heptagon, eight-sided octagon, nine-sided nonagon, ten-sided decagon, 11-sided undecagon, then 12-sided decagon. Then we also have irregular polygon. Irregular polygon is a polygon with different size and different angle. Okay, let me write something. Now, we said for triangle, it has three sides. Quadrilaterals, quadrilateral are four-sided figure like rhombus, parallelogram, then square. Then we also have pentagon, five, hexagon, six, heptagon, seven side, octagon, eight side, nonagon, nine side, decagon, 10 side, undecagon, 11, then dodecagon, 12. Now, this is a polygon, and let's check the name of this polygon. Let's count the number of sides. 1, 2, 3, 4, 5. And if you also count the number of angles, you realize that it is 5. So this is a pentagon. Now, these are interior angles. And then, let me show this. Let me call this plate theta. All these are interior angle. Why this is an exterior angle? Then, okay, this is interior, exterior. So exterior angle. One thing I want us to get from here is that the sum of interior angle, each interior angle and the exterior angle is equal to 180 angle on a straight line. Okay. Example 1. Okay. Calculate. Okay, let me do something. Sum of interior angle of a polygon. Formula. Now, the sum of interior angle of a polygon, you can calculate it using this formula, 2n minus 2, 2n minus 4 bracket 90 degree, or you use n minus 2 bracket 90 degree, where n is the number of side of the polygon. Now, example 1. Interior. Okay, hexagon. Calculate the sum of interior angles of a hexagon. The first thing we have to check is this: how many sides has a hexagon? That is 6. So we use the formula n minus 2 bracket 180 degree. Now you have n is 6, so I have 6 minus 2 bracket 180 degree, and that's 4 times 180 degree, and that gives us 720 degree. And this formula, we all know that the sum of angle in a triangle is 180. If you want to check n minus 2 bracket 180 for a triangle, a triangle has 3 sides. So by the time you substitute n as 3, you have 3 minus 1 bracket 180, and that being 3 minus 2 bracket 180, and that's 1 times 180, and that is 180 degree. And so that is why in this case, I can say for a triangle, it has how many number of a triangle has 1 number of triangle here, number of triangle in quadrilateral 2, number of triangle in pentagon 3, number of triangle in hexagon 4, and so on like that. Now, example 2. Calculate each interior angle of a pentagon. Okay, in terms of a regular. Okay, we have to calculate each interior angle of a regular pentagon. A pentagon has five sides, and a regular pentagon is a pentagon that has equal side and equal angle. So what we are going to do is that we are going to calculate the sum of interior angle of a pentagon, then divide it by the number of sides, which is 5. So for example, this is a pentagon. 1, 2, 3, 4, 5. So let's solve it. We have n minus 2 bracket 180. So pentagon is 5. I have 5 minus 2 bracket 180. So that's 3 times 180, and that gives me 540 degree. This 540 represents the sum of all the angles of the pentagon. Now, if they are all equal, if it is a regular pentagon, that means all sides are equal. In that case, I can say y plus y plus y plus y plus y for each angle. You know, 1, 2, 3, 4, 5 equals to 540. So 5y will now be 540 degree. So from here, then you divide both sides by 5. So we now have 5y equals to 540 degree. Then divide both sides by 5. So y equals to 108 degree. That means each interior angle of a regular pentagon is 108 degree. Then example 3. The sum of interior angles of a polygon is 22 right angles. How many sides has the polygon? Now, this is the approach. This is the formula for calculating the sum of interior angle of a polygon. And we have been told that it is now equal to 22 right angle. What is a right angle? The value of right angle is 90 degrees. That's multiplied by 90. This is what we mean by right angle. This is a right angle. The value here is 90 degrees. So I can decide to open the bracket or I divide through by 180 because the coefficient of n minus 2 here is 180 and we are looking for our n. So let me just make it easier. Let me divide both sides by 180. So I have n minus 2 bracket 180 equals to 22 times 90 then over 180 over 180. This one cancel this. So I have n minus 2 equals to here 1, here 2, 2 here 1, 2 here 11, 11. So n will now, I will now collect like terms, n will now be 11 minus 2 crossing the equal sign will become plus. So plus 2, so n equals to 13. So the number of sides is 13. So one thing I want us to pick from here is that when you are calculating the number of sides of polygon, it has to be whole number. If you get fraction, that means you are wrong. For example, if a teacher enters a class and asks the students for their number and one of them says we are 11 and a half, the next thing the teacher will say is, who is that half? So the same thing is applicable to polygon. For number of sides, it has to be whole number. Okay, let's continue. Now, for exterior angle of a polygon, these are what we call exterior angle. Exterior angle. Now, one thing I want us to know here is that the sum of exterior angle of any polygon is equal to 360. Whether pentagon, anagon, decagon, dodecagon. For exterior, the sum of the exterior angle of any polygon is 360 degrees. Okay, let me use example now. Let me use Yes, this is a typical example. So we have to find the value of y here. So these are exterior angles. So solution, I will have 50 degree plus 3y degree plus y degree plus 2y degree plus y plus 30 degree equals to 360 degree. So 50 plus this, that will give me 80 degree plus 3y plus 1y. The coefficient of y here is 1. That's 4y plus 2y, 6y, then plus 1y. That's 7y, 360 degree. So 7y will now be 360 degree minus 80 degree. So 7y will now be, this is 360 minus 80 for 240. 0, 280, 280 degree, 280. This is 280. So you divide both sides by 7. So y equals to 40 degree. So let me solve this question. Let me solve H. Irregular polygon is 150 degree. How many sides has the polygon? Yes, the question says each interior angle of a regular polygon is 150 degree. How many sides has the polygon? We have two approaches to solve this question. And I will make use of the two methods. Okay, let's say you have the polygon like this, you don't know the number of sides. Let's say you have it like this, you don't even know the number of sides. This is 150 degree. Now, this 150 degree, 150 degree, but then we don't know the number of sides. Let's make use of this. Let's call this exterior angle theta. Then we say theta plus 150 degree equals to 180 degree. Sum of angle on a straight line. I mentioned that earlier. Sum of angles on a straight line. So theta will now be 180 degree minus 150 degree. So theta will now be 30 degree. Then don't forget the formula. N will now be 360 over theta. So the number of sides here, N will now be 360 over theta is the exterior angle over 30. So, and that is 12. Alternatively, let me solve it in another way. I can have it as this n minus 2 brackets 180 divided by n. Just like what we did here when we calculated each interior angle of a regular pentagon. The total sum is of all the interior angle is 540 degree. We later divided by 5, which represents the number of sides. So that is why you have n here. So when you are calculating the number, the formula for each interior angle of a regular polygon is n minus 2 bracket 180 divided by n. So then this one equals 150 degree from the question that we have been given. So if I cross multiply here, I will have 150n equals to n minus 2 bracket 180 degree. Then I will open the bracket. 150n equals to 180n minus 360. So if I collect like terms here, I can have 360 equals to 180n. This one has plus, crossing the bridge, it's returned to crossing the equal sign, it's returned to minus 150n. So 360 equals to 30n. Then divide both sides by 30. So I have 30, 360, 30n. 30 is the coefficient of n. That's why we're dividing by 30. So n 12 equals to n. Therefore, our n equals to 12. Okay, having understood the rudiments of polygon, then let's go for general questions. Okay, let's quickly solve this one. Okay, solution. Now, the first one says the exterior angle of a regular polygon is 60 degrees. Find the sum of the interior angle. So I have n equals to 360 over theta, where theta is the exterior angle. So I have to get the number of side here. So n will now be 360 divided by 60. So n equals to 6. Therefore, number of side is 6. So for the sum of interior angle, I will now have n minus 2 bracket 180 degrees. Our n here is 6. Apparently, the polygon is a hexagon. So I have 6 minus 2 bracket 180. And that's 4 times 180. And that gives me 720 degrees. Then the second one, we have to find the value of s here. Now, we have to calculate. Let me count the number of angles. 1, 2, 3, 4, 5. So that means the polygon is a pentagon. And if you count the number of sides, it will still give you 5. 1, 2, 3, 1, 2, 3, 4, 5. So the sum of everything here must be equal to 540. That's for pentagon, but we show it here. So I have s plus 80. The value of this is 90 degrees, and the value of this is also 90 degrees. So that's plus 90 degrees plus 90 degrees equals to n minus 2 bracket 180, sum of interior angle of any polygon. So this one will be 2s plus, this is 180, 180 plus 80, that's 260. 260 equals to 5, n is 5 minus 2 bracket 180. So 2s plus 260 equals to 3 times 180 degree. So 2s plus 260 equals to 540. Then we collect like degree. We collect like terms. So 2s will now be 540 minus 260. So I have 540 minus 260. That's 0, 14, that's 8. 8, 280. So I have 2s equals to 280. Then I'll divide both sides by 2. So s my s here is 140 degree. Then number 3. How many triangles are in a polygon of y side? Okay, instead of n, the question is referring to using, the question is saying y side instead of n side. So I will have it like this. Normally we write n minus 2 bracket 180, sum of interior angle of any polygon. So in this case, the question is saying y. So I will, instead of n here, I'll put y. So how many triangles do I have here? Of course, we know that the sum of angle in a triangle is 180. That means, for example, if I say how many fives do I have in 15? That means I have to say 15 divided by 5, and that will be 3. The same way, the same thing is applicable here. How many triangles do I have here? Of course, the sum of all the angles in the triangle is 180. That means I have to divide this one by 180. So I have y minus 2 bracket 180 divided by 180. So the answer here is y minus 2. Yes, triangles. Y minus 2 triangles. That's it. Then number 4. The sum of interior angles of a pentagon is 6s plus 6y. Express y in terms of s. Okay? So I have 6s plus 6y equals to n minus 2 bracket 180. So 6s plus 6y equals, pentagon is 5 side, 5 minus 2 bracket 180 degree. So 6s plus 6y equals to 3 times 180 degree. So I have to express y in terms of s. So I have 6s plus 6y equals to 540. So I have 6y will now be 540 degree minus 6s. This one has plus, crossing the bridge it return to minus. So 6y, I will divide both sides by 6. Since 6 is the coefficient of y, so I have 6y equals to 540 degree minus 6s divided by 6 divided by 6. So y will now be, now there is something we call splitting in mathematics. Once we realize that the denominator is a factor of any of what you have as your denominator, as your numerator. For example, if you have something like this, let me say even 9 divided by 2, you can split it. This one will now be 6s over 2 plus 9y over 2. So you now have it as 3s plus 9y over 2. So the same way here, I can now split. By splitting, I will have y will now be 540 degree over 6 minus 6s over 6. So y will now be 90 degree minus s. So that will be the value. Then number 5. Okay, yes. So please, okay, we have done something of this nature. The answer is 48 degree. Check. Then in this case, we have done something of this nature as well. The answer is 18. You do that yourself. Okay, number 7. We have find the value of A. Now let's check the, the polygon. We have 1, 2, 3, 4, 5. The number of sides here is 5, and the number of angles is 5. So it's a pentagon. So this shape is a pentagon. Then let's calculate the sum, and then we know the value of P. So I have 50 degree plus 105 degree plus 105 degree plus 50 degree plus B equals to n minus 2 bracket 180 degree. So this is 100. Okay, 100 plus, that's a 210. Okay, so this one will be 310 degree plus B equals to 5 minus 2 bracket 180 degree. 310 degree plus B equals to 3 times 180 degree. So 310 degree plus B equals to 540 degree. So let's collect like terms. B will now be 540 degree minus 310 degree. So I have 540, that's 230. So B equals to 230 degree. Then we are looking for A, the value of A. I can now say A plus B equals to 360 degree. A plus B, angle A plus angle B equals to 360. The reason is that angle at a point, angles at a point, the sum of angles at a point is 360, forming a complete revolution here. So I have A plus 230 degree equals to 360 degree. So A will now be 360 degree minus 230 degree. A will now be, so 130 degree. Then number 8. I have the ratio of interior angle of a pentagon is this 2 ratio 3, 2 ratio 3 ratio 4 ratio 4 ratio 5. Find the smallest angle. Okay, of course, from what we have been doing, even from here, you know that the sum of interior angle of a pentagon is 540. So for the smallest, so I have, let me even add everything together. 2 plus 3 plus 4 plus 4 plus 5. That gives me 18. So for the smallest angle apparently is 2. So I have 2 out of 18 times 540. 540 being the sum of angle of a pentagon, something of this nature. So I can say 2 here, 9, okay. 18 here, 1, 18 in this is 30. So 30 times 2, that's a 60 degree. So that's the value of the smallest angle. Then number 9, I have the sum of angle of a regular polygon is 1800. So I have n minus 2 bracket 180, because this is the formula for calculating the sum of interior angle of any polygon, equals to 180. So I can divide both sides by 180. So I will have n minus 2 bracket 180 degree equals to 1800 by 180 divided by 180. So n minus 2 will now be 10. N will now be 10 plus 2. So n equals to 12. So the question now says the size of the exterior angle. So the side of the exterior angle. So I have n equals to 360 over theta. So theta is the exterior angle. We have our n as 12. So 12 equals to 360 over theta. If you cross multiply, I have 12 theta equals to 360 degree. So divide both sides by 12. Theta here is 30 degree. Okay, let's go for another round of general question before we call it a day. Yes, sir. Number 10. That should be. Okay, let's quickly solve these questions. The first one says, two of the exterior angles of a polygon are 63 degrees each. The remaining exterior angles are 26 degrees each. Find the number of side of the polygon. We know that the sum of exterior angle of any polygon is 360. So what we will do is this. I have a 63 degree plus another 63 degree plus, let's say you have something like this. This is what we are saying. 63 degree, 63 degree. Then we have other sides. We don't know the number of sides. So let's say that's 26 degree. We don't know the exact number. So plus 26 degree times, let's denote the number of the remaining side with S. Will now give me 360 degrees. Sum of exterior angle of a polygon. So this one will give me 126 degree plus 26S equals to 360 degree. So I have 26S will now be 360 degree minus 126. So 360 minus 126, that's a 4. That's 3, 234. So 26S will now be 234 degree. Then I'll divide both sides by 26. Okay, so S 26, 2 here 13, 2 here 117, 13 here, that should be 7. There's 7. S is 7. Therefore, S is 7. Then the number of sides of the polygon is, that's 7. This S is 7, then plus 1, 2 that's 9. That's it, 9 sides. So the polygon is a non-agon. Then let me check. 21. No. 117. That's 113 divided by. I have 26S equals to 334. If you divide both sides by 26, S equals to 9. So therefore, the number of sides of the polygon is 9 plus 1, 2. That's 11 side. It's 11. Okay, this one, we've done something of this nature before. So just solve this one. This is 90 degree. Then the answer is 70. All right, let me solve this. The sum of interior angle of a regular polygon with S side is 3S minus 10 right hand. So sum of interior angle 10 minus 2 bracket 180 equals to. But in this case, right angle means 90. In this case, the number of sides given here is S. So you are using, instead of N, you write S. So the sum of interior angle of a polygon given is 3S minus 10 right angle, and right angle is 90. So in this case, to make it easier, I will divide by 90. Divide both sides by 90 degree, and I have S minus 2 bracket 180 over 90 degree equals to 3S minus 10 over 90 degree times 90 degree. So this one cancel out this one here. So I have S minus 2, this one is 2, bracket 2 equals to 3s minus 10. So I will open the bracket here. I have 2s minus 4 equals to 3s minus 10. So if I collect like terms are minus 4, this 10 is the owner of this minus, then plus 10 equals to 3s plus here, 2s as plus here, crossing in equals minus. So 6 equals to s. So s equals to 6. Therefore, the number outside is 6. So we have to find the size of the exterior angle. So n equals to 360 over theta. N in this case is s, and that's 6 equals to 360 over theta. So 6 theta being the exterior angle equals to 360, then divide both sides by 6. So theta equals to 60 degree. Then number 4. The ratio of the exterior angle of a regular polygon to the interior angle is 1:3. Exterior angle. So for exterior angle, you have 360. Each exterior angle they divided by n. Then the interior angle is n minus 2 bracket 180. Each interior angle divided by n. So the ratio here equals to 1/3. Okay, let me clean this side. And I have a space. So I have, this is each exterior angle of a polygon, and this is each interior angle of a polygon. We divide by n as well. So the ratio we have been told is what? 1:3. So I have 360 over n divided by n minus 2. This is major division line, and that's been represented by this, into 180 divided by n equals to 1/3. So I have 360 over n times n over n minus 2 bracket 180 equals to 1/3. N cancel out n. So I have 360 over n minus 2 bracket 180 equals to 1/3. So I will cross multiply. So if I cross multiply, I have n minus 2 bracket 180 multiplied by 1. That will now alter the value, equals to 3 times 360. So the coefficient of n minus 2 here is 180. So I will divide both sides by 180. Okay, I can do it straight since I have multiplication here. So n minus 2 equals to here 1, here 2, 6. 2 times 3 is 6. So n will now be 6 plus 2. N will now be 8. So the number outside is 8. So the polygon is octagon. The next one, number 5, says the interior angle of a regular polygon. Okay? Interior angle of a regular polygon. That's n minus 2 over 180. Each interior angle is 5 times the exterior angle. Is 5 times the exterior angle. Each exterior angle. So this is what we have. This each interior angle of a regular polygon. Each interior angle of a regular polygon. Each interior angle of a each exterior angle of a regular polygon. So we have it as each interior angle of a regular polygon is 5 times each exterior angle of a regular polygon. So I will have n minus 2 bracket 180 over n equals to 5 times, this is 5/1, 5 times 360 over n. Then I will cross multiply. If I cross multiply, I will have n into n minus 2 bracket 180 equals to n times 5 times 360. So if I divide through by n, this n will cancel out this. So I will have n minus 2 bracket 180 equals to 5 times 360. So I'll divide both sides by 180 degree. So I have n minus 2 bracket 180 equals to 5 times 360 degree. So 180 degree, I divide both sides by 180 degree. So n minus 2 will now be, this is 2, that's 10. So n will now be 10 plus 2, n will now be 12. Okay, so the number of sides is, then the number 6. I have, which of the following is or are not interior angle? Oh, I didn't write that. Let me write something like this. Which of the following is or are not interior angle of a regular polygon? Let's say 120, 150 degree, 10, 105 degree. Okay, let's, this is Roman figure 2, Roman figure 3. Which of the following is or are not interior angle of a regular polygon? Let's check 120. We have something like this, 120. So by the time you calculate this one, your theta plus 120 degree will give you 180 degrees. I'm going a straight line. So theta will be 180 degree minus 120 degree. Theta will be 60 degree. So n equals to 360 over theta. So n equals to 360 over 60. And that's 6. Okay? That's a whole number. That means 120 degrees is possible for interior angle of a regular polygon. Let's check 150. Let's check 150. Let me use this side. 150 degree. Apparently, if I follow the same procedure here, my theta will be 30. So n will be 360 over 30, and that's 12. Yes, whole number. 150 is possible. Then let's check 105. If I use 105, apparently this one will be 75. Theta plus 105 equals 180 degree. I'm going a straight line. So in this case, theta will be 180 degree minus 105. So theta equals to 75. Let's now check. Theta will now be 360 over n. Okay, so we now have 360. So theta equals to 360 divided by 75. So 360 divided by 75. That's theta equals to, oh, so n here, sorry. N equals to 360 divided, the theta is 75. So n. So n equals to 360 over theta. Our theta in this case is 75, which is this. So 360 divided by, that's 4.8. And remember I said, when you are calculating the number of sides of polygon, you cannot get decimal. So it's only these two that are possible for interior angle of a regular polygon. Then number 7. Number 7. A polygon of n side is such that each interior angle is, okay, let's draw something of this nature. Each interior, such that each interior angle is 120 greater than the exterior angle. So if the exterior angle is S, the interior angle will be S plus 120 degrees, because each interior angle is 120 greater than the exterior angle. So I can say S plus 120 degree equals to 180. Sum of angles in a triangle. So 2s plus 120 degree equals to 180 degree. 2s will now be 180 degree minus 120 degree. 2s will now be 60. So divide both sides by 2, s equals to 30 degree. So the exterior angle here is 30 degree. Then we have to find the number of sides. So n equals to 360 over theta. Theta is the exterior angle, which is 30 in this case. So n equals to 360 over 30, and that is 12. So that's the number of sides is 12. Then the sum of all the interior angle. So the sum of all in the interior angle, so n minus 2 bracket 180 degree. So 12 minus 2 bracket 180 degree. So 10 times 180 degree. So then that will be 1800 degree, 1800 degree. Then the last but not the least, for which of the following angle is the exterior angle of a polygon possible? Okay, you have been given the exterior angle. So all you need to do is say the first one, let's take the first one, 360 divided by exterior angle, let's say 50. Apparently that will give you decimal. That's a 5.7. So 36 divided by 5. So that was 7.2. So this is not possible because I said it earlier that the number of sides must be whole number. Then the other one, n equals to 360 over 18. Okay, this is 20. And this is possible. That one is possible. Then the other one, the last, but then the least there, n equals to 360. Exterior angle is 45. Then let's quickly check 360 divided by 45. So that is 8. So it's possible. So that means this is possible, and this is not possible. Thank you.